Thank you guys so much for being here today. So I was really intrigued to hear about your company. I'm still trying to wrap my head around exactly how it works. But I mean, we all basically understand that there are battery recycling companies. We've maybe on this channel heard of Redwood Materials, which has JB Straubel as its founder. And so I was really excited to talk to you guys today because we all know that this is something we need to be doing more and more of. We need to be recycling our batteries. But I think a lot of people have questions about what happens when you're done with a battery. So maybe you could just walk us through on a real kind of sky view level of what happens to my battery, either in my car or my appliance when I'm done with it. Where does it go when I think I'm doing the right thing by bringing it to, Lowe's or something and sticking it into the battery recycling box?
Well, if it's a small consumer electronics box, there's a battery, there's a different flow chart for where it goes. If it's a electric vehicle size battery, the majority of them don't get to actually wear out, like using their useful cycle life. They often fail from internal corrosion issues in advance of that natural cycle life. You can see the Nissan Leaf internal corrosion recall or the Bolt internal corrosion recall. Those are examples where all of those packs will be replaced without reaching their useful end of life. And so because of those types of failure modes, you can't actually rely on the system's internal to be functional to discharge them or to perform normal safety behavior that you would use if you had a perfectly functional battery. So that's kind of one of the big challenges you enter is if the pack is working great, then sure, you can safely discharge it to nothing. But you have to be able to deal with the packs that just got in a car wreck and like the side of the battery that has the discharge connectors torn off by a truck or whatever happened to it. You can't rely on these things being functional, or it's filled with water from a flood or whatever happened to it.
Okay, so walk me through that then. I just got into a wreck with my Bolt, let's say. The battery is giving all sorts of weird error messages and stuff, and basically the car's totaled. Now what happens to that battery?
Batteries, when they're destroyed and they need to be recycled, basically there's not a good place for it to go at this point. So you have amazing companies like Call to Recycle that have set up these different logistics ways to drop your battery off at Home Depot and things like that. But you have major companies that at a corporate level are taking apart scooters and e-bikes that they've made that don't survive these corrosion issues that Luke was touching on, and basically just go into a warehouse or a shipping container and are waiting. But a lot of times these kinds of batteries, because of those issues, create molten salt bridges or get water inside of them, and then they just have a thermal event, to say it very lightly.
Then a lot of batteries are just sitting around in warehouses or dumpsters and kind of waiting for someone to come up with a solution. You guys have a potential solution here. Can you tell us what that is?
Yeah, so the car wreck lets you get into, God forbid, a car wreck with your Chevy Bolt. And now, usually, if it's completely totaled, it goes to a junkyard. These people have been doing junkyard things for many years, sometimes many generations. And this is the first time that they're dealing with packs that are high enough voltage that if you touch them while they're damaged, they could kill you. And that really changes the game here. And so our solution to that was, instead of putting more people at risk, like your logistics people to come and you pay tens of thousands of dollars to get the right permits, to get the right training, to bring it onto a truck, to drive it somewhere else, and then you're putting people on the highway in danger because you don't know the status of this, is to come on site and just shred the battery while it's there. And our shredder process is, it's called redi-shred, and that is our way of being able to make the batteries safe, to go ahead and shred them.
So in that situation where you wreck your Bolt, someone's still got to extract it from the vehicle carcass, right? And our process has no answer for that, extracting it from the vehicle carcass. That's still going to be someone using heavy equipment at an auto wrecking yard to get the pack out. Once the pack is out, in whatever shape they extracted it, and with whatever parts of the car members still attached to it, let's say, then provided it fits in the mouth of the shredder, we'll shred it, and we don't need to take it apart any further than what it takes to fit in the mouth of the shredder, which is a very large mouth. We can shred Tesla packs whole.
Wait, so it doesn't explode?
Yeah, because every single pack of batteries that I've ever seen has a sticker on it somewhere, and it says, do not puncture, do not crush, do not, don't do any of that. So what happened? You just take it and you put it in a shredder?
Maybe like 15 years ago, I was making YouTube videos of every kind of way you can torture a battery, from stabbing things through them to torching them to cutting them in half and everything in between. But there's actually a trick that you can render the thermal kinetics so slow that your time constants aren't a problem for shredding them. We can just say it's Arrhenius equation related, but that'll mean enough to the people that would get the info.
So if I take this battery right now and I get a pair of big scissors and I cut it in half, isn't it going to explode if it's charged at all?
You'll probably get burned. Yeah, I can show you the videos of what happens when you shoot nails into them, and at a full state of charge, and it's pretty aggressive. You'll get a
even
nice
at a low
fire.
state of charge, you still have pretty big issues
Even
there.
at mid state of charge, you get pretty big issues. Well, if you took that same battery and you left it overnight on dry ice, let's say, just as an example, and then in the morning you pulled it out, and while it was still very chilly, you did that same torture you were going to do, sticking your scissors through it or whatever you're going to do, you would find there's this period where because ionic behavior, the ability for the cell to make current and generate heat is effectively limited by temperature in the thermal kinetics of diffusing ions. And so for every 10 degrees cooler that the cell gets, you have roughly half the rate that this current generation chemistry can occur. And so when you're at, say, minus 60, the rate that this current production can occur is almost nothing. If you put that battery at minus 60 in your flashlight or whatever, and you turned it on, to use it, it would be like the worst performance you've ever seen, from a ionic potential. In fact, it might not even be able to light your light bulb, right? It might not even be able to make like 1/2 amp to light your light bulb.
And so like when I'm, because I have a Leaf and a Model 3, and it's currently 9 degrees in the morning, and the battery, the range is significantly reduced, but that's still, 9 degrees Fahrenheit. You're saying negative 60 degrees Fahrenheit or Celsius?
No, negative 60 C.
Wow. Yeah. So that's very nippy.
Yeah. So imagine you notice that decrease in your Leaf's performance when you're at 9 degrees C, but imagine if you have something like 50 plus times higher impedance. So it would be the tamest Leaf pack ever. It would be a Leaf pack with a capable max discharge performance of like a couple of horsepower would be all you could extract from it, at that temperature. And so that's also why it's inert to the shredder and behaves completely different at those temperatures than it does if you were to shred it at room temperature.
So Erika and Luke, why did you get into recycling in the first place? Is this something you were born just dying to do?
No.
Yeah, pretty much no.
No, it was more like guilt forced us into recycling. I don't know.
Well, when he says guilt, because we've built so many batteries, like prototyping is so much fun, right?
And R&D.
But bringing things into production is like hell, right? That's what you usually hear, right? But the issue is that if you don't take care of these issues we're talking about today at an early stage, then you just have the same problem at a larger scale. So when you create a lot of e-waste and you're just looking to other people to solve the issue that you've contributed to, a lot of times you really have to be able to solve your own problems.
Yep.
You can't just necessarily ignore it and think someone else will do it, because that's kind of like the bystander effect.
Yep. Since 2011, when I started first making R&D battery scrap waste, at a professional level of making battery R&D testing, I thought someone's going to get on this waste scrap pickup real quick, and these things are going to be hot commodities as little ore treasure troves in a box, of valuable materials to recycle. And still waiting for someone to come in with a good process that's efficient and clean for the earth and makes sense. And so started cracking that nut ourselves eventually, and cracked it wide open to a point that comfortable and confident with the process and efficiency and materials returned.
It's not an easy issue to solve, and a lot of our clients asked us what to do, and because we didn't have an answer that we felt good enough giving to them, that's when we decided that is kind of our calling. I mean, Luke and I talk all the time that our whole purpose on being on this earth is being able to share whatever skills we've been given so we can ascend and travel the universe after this, right? You just got to make Earth a good place first.
Yep.
Okay, so your technology means that you can show up to a junkyard or wherever this battery has its first stop, and you can recycle it basically to a state where it's safe to transport.
That's exactly right. And
you have the wow factor too while you're there.
well, I like the advantage that I've been in recycling batteries for a long time. Making batteries and paying to have them recycled, right? And Erika has too, in the process of making batteries. And the big trick that I really like with our process is every time your waste leaves, let's say it's R&D test waste, because I'm usually on the R&D side of developing battery solutions. So you've got batteries that you've tortured in all kinds of ways, from penetrating things through them and crushing them to over temperature to salt baths to every kind of torture test you can imagine. And now they're in this unknown state after these tests where maybe one side of it burned, one side of it didn't burn. You don't know the condition these things are in. And so you load them all up on the recycling truck, and then you don't really know if it's even going to make it where it's going, because you have no way to say whether or not that R&D test scrap waste, just like after you wreck your GM Bolt, like the guy really has no way of ensuring I know this won't catch fire in the next 5 minutes, because you don't know where those wires that were stripped back or that insulation that was broken, or whatever's filling with liquid to make a salt bridge, you don't know where it is. And this process takes the ambiguity out of shipping. It basically takes all the risk out of the process, because you see some videos occasionally of people with a battery recycling center, and they're wheeling in some EV battery indoors in a place, that's not like a stainless ceiling. It's like a normal building, and then they, do some processes indoors with it and then put it into some other process, and it's completely unrealistic. It would be an OSHA hazard to even allow a real battery ready for recycling in that enclosed environment with people, because you have no idea what the behavior of that pack will be, and you can't guarantee that while you're rolling it in the building, it's not going to incinerate. And that's why our process is essentially prepared for your test scrap at any point in our process to unexpectedly catch fire, to unexpectedly arc flash, to combust, whatever it needs to do. And our process is expecting that and ready for that. A lot of people say we can only recycle batteries if it's at a, empty state of charge, let's say below 10% or something, And the reality is, when you get in a car wreck, you could have just gotten that car wreck right after you unplugged from the charger. And so processes that can only handle these kinds of limited niche conditions are not realistic for a viable solution moving forward. And that's why we created the solution to address that.
I also just want to put as an anecdote that just to shift the American mindset a little bit, recycling is definitely a last step, right? And so we're kind of approaching this from a holistic perspective, which is why we also have our consulting business, because you want to refuse to make bad product, right? Reduce the amount that you need in order to test and streamline that. And then also make something good enough that you can reuse it. Because when you are going through recycling, it's very expensive to the environment. You add a lot, it's kind of like a race to the bottom to reclaim those materials. And we're really just doing it as a last ditch effort, because you want to encourage development with a lot of these different companies now, as well as having an end-all solution if you do get to that point, which there's many tons of e-waste on this planet right now.
We were talking earlier, and I think you were mentioning that a lot of batteries just end up being in dumpster fires because people, they're well-intentioned, but there's nothing that people can do with them.
That's right. Yeah, that's kind of been a blemish in battery recycling, but many early lithium battery recycling companies' business model was basically to collect all the batteries you can and leave them in a metal dumpster outside until it burns, and then you get insurance payment on the losses of what you had. And that's kind of an unfortunate blight in the industry, and we're trying to change that to make real recycling that works. And like what Erika was bringing up with the second life potential, like it would be wonderful to get to second life everything instead of recycle it. When they have things like the GM Bolt or the Nissan Leaf issue, which is corrosion based, then the second life potential is almost missing entirely. Because let's say you're trying to do like the warehouse of batteries for grid storage or whatever, it only takes one bad seed in there, for your whole facility to burn down. And so once people build packs where they respect the tremendous challenges of preventing corrosion, that's electrically driven corrosion in a battery, then we'll be able to second life things much more often. And then, it only makes a lull in the recycling burden though. They'll need to be the same amount of packs recycled, whether you second life them or not. It'll just be when that time shift occurs.
It's funny that so many people that are interested in EVs and, all sorts of battery powered stuff, end of life kind of gets ignored. And I mean, that's not a new thing. I mean, for cars and stuff, of course, we knew that there were junkyards, but there wasn't much in terms of recycling aside from crushing it up, melting it down, and maybe you'll get the steel out of it, maybe you'll get the plastic out of it, but probably not. It's probably going to sit somewhere. It's just that with an EV, you really can't have that happen, because it's like having a firebomb somewhere in the car that could go off at any moment.
That's exactly right. And there's no PPE that exists that you could put a worker in to have them near it. If you do the arc flash calculations for these kinds of tests, there's absolutely no PPE that provides you resistance. There's just levels of severity you'll be injured in that situation. But the shredder can process it all into confetti rapidly. And so having the human flesh be risked in that process seems ridiculous to me.
So to talk a little bit more about the redi-shred process. So you're taking something which is essentially, I'm imagining like the Hurt Locker. The guy's going out to the thing, it might explode on him, you don't know what's going to happen. Instead of having to do that and try and, disarm this battery, you can essentially slow down time for it. Because by cooling things off, you're essentially slowing down time. It's as if even if it were to explode, it's just going like, you just slow explosion, and he can, put a bag over it and just be like, okay, my job's done. Put it over his shoulder. I mean, that's essentially what you're doing.
Yep, and we could show you videos of what happens when you shred the cells at full states of charge when they're cold enough, and you see an occasional little wisp of electrolyte vapor when, maybe it could discharge a couple of amps or something for a moment, and so you make a little bit of heat here and there, and overall, though, it's just cool shreds falling out.
Okay, so you were talking about scrubbers and stuff when we were talking about your shredder. So this isn't just some shredder and then you end up with a big pile of stuff on the ground, right? Like, what else goes into this?
The shreds all fall into an aqueous pH buffer neutralizing solution. And that's why even if, let's say, you get some hot pieces that are coming out, maybe some part of the cell wasn't completely blast chilled, it falls and just makes a little, as it boils water for a split second, and the energy is released. In this tank, there's the right mix of ionic diffusion paths to allow everything to reach a common entropy level of chemistry state. Yeah, essentially that's why we can take any state of charge battery, and we know that before it's ever dry, so before it's ever out of our pH aqueous brine solution, it has already realized like a zero entropy, where it's as non-dangerous as bits of aluminum foil or copper foil you might have laying around in your kitchen or whatever. It's as unlikely to cause a problem as those materials afterward.
So before people, take their battery off the dry ice and cut it in half, there is another step. It's not just cooling it off, because once it comes back up to temperature, everything speeds back up and it'll catch on fire. So it's amazing. So you have this solution that you it's a solution and a solution that you dump all of the shreds into, and that neutralizes everything, and then you're left with battery confetti.
And there's also the, you mentioned what do you do if it starts to warm up again, of course, and that's why you have to not have the shredder jam. And from the time you start feeding a Tesla pack, let's say, you need to not stop that feeding of it until it's finished, because it's going to be warming up as it goes, and it'll be developing the ability to deliver more current as it goes. However, it'll also be losing cells to join that ability to dump current. And we always shred from the side of the pack that has the lowest potential to bite you. So, for example, on a Tesla pack, you can shred from the output terminal side and you'll take the full pack voltage. But if you shred from the opposing side, you'll take something like 1/3 string voltage as max potential difference you see as you're shredding.
Okay, so just from a money point of view, though, you just saved somebody a whole lot of money by showing up with this truck, right? Because otherwise, I would have had to take that bolt pack and figure out how to transport it. And like you just said, it's super dangerous, and I probably don't know how to deal with it. So I have to get permits, and I have to hire experts and do all this stuff just to move it down the road to the next stop. Whereas you guys now have it, you've solved that problem.
Yeah, I think it's as big as the advantages in our recycling process are. I think is the truck process, just because having been on the customer side of needing battery recycling many times, this was kind of the dream I always wished could show up on site and neutralize all these R&D experiments into something safe.
So right now we're working with our different strategic partners and looking for individual investors as well as venture capital. And the way that we're not the money people at all in this business, but the way that our business partners have laid this out is that redi-shred is really going to help us get out there and let people know that this is what we're doing. And it also is going to allow us to secure different types of battery feed. Because it's like Luke was saying, it's going to be way easier for someone to call us and us to show up and then take it on out to our second part of our company, which is called redi-cycle, REDI-cycle, and continue to get those materials. And Luke can definitely get into this, but in the layman's terms, like we deeply respect and admire the recycling companies that are out there right now. It's a humanitarian issue. We definitely need it for the planet, like we said. We really would love to see the smelting process removed. And that's just burning and melting all of these things, because there's a lot of energy that goes into that. There's also just like gases released, so you need to scrub it a lot more. And that's essentially one of the major things that we look to in our process at the recycling stage to get rid of.
Yeah, we have no roasting before smelting and no smelting. So two processes that are normally thermally done to process batteries, and we've managed to eliminate both of them by using significantly more earth-friendly processes.
It looks like from your deck that I'm looking at here, you're able to get really high percentages back of the things that are in the battery, lithium, the copper, the nickel, and so forth. And yet you're not doing what I think I saw being done at, say, Redwood. Like at Redwood, I saw like a big smelter and I saw molten something coming out of it. How are you able to do that in layman's terms? Is there a way to describe it?
That's kind of our secret sauce, I would say. We're definitely not super into patents, but our business partners, very rightfully so, to protect our investors and whatnot, have filed the right paperwork and everything. So these are all things that we own as a company, and we hope to share with the world as soon as we get our pilot production and production plant up and running.
Okay, so let's treat redi-cycle as a black box. Yep. You take the confetti, you bring it in. What comes out of the redi-cycle?
One of the output products is 99.99% pure nickel metal form.
It's pretty cool. Like we took Tesla batteries and then we just received strips of nickel.
It was a lot more work than just receiving it. I think it was like
black box.
It was like a month of you get nickel, cobalt, manganese, copper, aluminum, steel, lithium, and even fluoride salts all out as processes, because everything that's in the cell has to go somewhere, right? And so if we don't have it as an output material, then it's a waste stream that accumulates, right? So we have to have everything that goes in the cell as a output material ultimately.
You've probably heard this too. It becomes a material science problem, or opportunity really, because there's so many different polymers and different kinds of metals of different purities that you can find a second home for. And I love thinking about using geopolymers to like capture carbon in the air somehow and like make houses out of it and things like that.
The polymer scrap is actually good for doing something like a geopolymer application. But that's a whole different business on its own that would be just as bigger than the recycling business. So,
and that's our strategic partners as well that we're
that's for other companies to do. We want to just focus on recycling batteries.
So, I mean, you could take the materials you get out of this process and basically turn right around and make batteries with them.
What we're saying is definitely different than what the industry is talking about, right? You get a lot of those flowcharts that show that circular battery economy, which is definitely a good place to get to. But going off what Luke and I have been talking about is that there's batteries there today that we need to do something with. And this is our opportunity to start gathering those and doing the research and development and putting those materials back into places where they could use those lower purities. And it makes sense to the people who are counting their nickels and dimes, which is very important in business. And then go from there to eventually, hopefully, getting back into the battery economy. But I know a lot of other people are focused on that as well, too. I just don't know as far as where our technology is, if we're going to be able to do that right away.
Yeah, at the moment, there's ample buyers for nickel that is slightly lower purity than battery grade purity.
It's also much different to be recycling right off of, let's say, Panasonic's battery line, where when you build cells, you have a bunch that fall out for quality control. And if you're able to get those jelly rolls or those materials and those layers right directly off of that and recycle it, it's a very much different process than getting your crash bolt battery, which has all the different parts surrounded on it, and it kind of cuts that human factor into it.
So you're more looking at, the batteries that we can't save, that didn't have the perfect life, so to speak. Not necessarily the like, hey, I've driven my Tesla for 200,000 miles and now it's down to 80% battery life, and I want to turn it in, and now let's pull the batteries apart. Instead, we would probably take those batteries and put them into some stationary storage, and then once those batteries got low enough, we would feel comfortable enough to take those batteries apart in some other process, kind of like the one you were talking about at Panasonic right off the line, right?
Well,
that's kind of an interesting, another like rhetoric thing that goes around in this industry of needing to take the batteries apart to reuse them. And that kind of goes... I think
you've already failed. If at any point you have humans disassembling EV packs, you've failed mission 1, which is like respecting human life.
Oh, I'm talking about, Terminator robots.
Even Terminator Robots would be better to just feed it into the shredder. There's nothing in there that you would be wanting at that point, especially after you'd used it for a Second Life application already. The first step we need before Second Life becomes real even is OEMs need to make their packs live the first life and complete the first life. And most OEMs can't achieve that today. And so after everyone's achieving first life, then Second Life will have a viable path forward, And but regardless, the recycling flowchart will be no different after Second Life. It'll just be, again, a time shift in when it gets recycled, but ultimately it just goes in the shredder.
That's an interesting thing to point out then, because I think that this, again, makes your process even more valuable, because it's going to have to go to the shredder at some point. There is no taking apart the cells, essentially.
That's right. There's no taking it apart. It's going to shredder. And there's another misconception too. People often say, I don't know how this misconception got started, but they say, I'd like to pop my battery, but then I can't recycle it.
And we hear this fully encapsulating the cells to protect them from the environment.
Yeah, we hear this from educated people and engineers and like all kinds of things who just somehow in people's minds, they think that if you're potted, you can't be recycled. But our shredder makes no consideration or difference. It doesn't even affect the RPM speed of the shredding. to be potted or not potted. If you're a monolithic brick of potting, if you've got layers of steel or armor plates or whatever's under the vehicle, to protect it, the shredder teeth don't care at all. And it all goes out in the separation stages that separate plastics from metals and dense materials, later down the stream. And so you can encapsulate your battery, do your very best to protect that battery environmentally using every trick you can to stop corrosion and avoid vibration problems and resonance problems. And then we will shred it at the end of whatever you did to protect it. And our shredder will not be impressed by whatever you did to protect your battery.
So, I think that there's this broad misconception out there that if only we could get those batteries, we could take them apart, unscrew the lid, and pull out all the good stuff. And then we would just, someone would sit there with a credit card, I guess, and just, scooch all the good electrolyte, put that over there. Then we'd put it in a hopper, and then we would just put it all back together, and it would magically, boom, battery again. And we would, that's, you're basically saying that's not realistic.
It's realistic up to the point that it goes through the shredder and becomes chips and then can slowly make that conversion back to battery again. But for our process, the costing doesn't make sense to refine it so highly to be battery grade again when the processing is significantly lower cost and faster to make, say, 99.99% pure nickel instead of the battery grade purity of nickel.
There's also companies that are doing what you're talking about too, Zac, where they are taking apart those packs and they are pulling the cells out and they are making new packs. And that's really respectable. And I think that it's really great to be doing that on a human level. It's more of how does that scale and how do you fix it from a holistic perspective? It's just kind of a Band-Aid from our view as far as doing it that way.
They also have no idea the state of condition of contact or contact pads inside there or any assemblies that have corrosion that's internal that they can't see, and so they're really rolling a dice with other people's safety when they reuse EV parts. And I don't personally see that working out as a business model. But I know that there's people out there doing it for the DIY crowd that wants to make their own home lawnmower electric or whatever, and they sell packs to them online.
We're not experts at all in this subject too, so we totally would welcome the conversation with the owners of those businesses as well, because it is really important to share their stories on how they got there so we can improve in the future as well.
Now, can you do this at a smaller scale, like mobile phone batteries and laptop batteries and stuff like that, or is it just bolts?
In our lab right now, I'm doing a batch of pure cobalt oxide phone batteries, actually. So, yes.
Our process is definitely flexible to these different kinds of chemistries, but maybe, Luke, you want to talk about which chemistries we are not really looking at?
Yeah, we're not looking at iron phosphate at the moment just because it appears that it would run cost negative with the current processing cycle because we get to reclaim copper, aluminum, lithium, graphite, and that's the only valuable materials that we get back out of it. And iron phosphate, the process works with every known cathode or anode material that I'm aware of today. However, it's variable on your percentage processing cost versus output materials gleaned from those different materials, so that if you could get a feedstock of just mobile phone batteries, you would, that would be like the best case scenario. But realistically, you're not going to get, like hundreds of tons of mobile phone batteries all the time, right? It's just, that's where EV packs come in, because that's really where the volume is in batteries right now.
And based on our business plan, all the batteries from 10 years ago that are still sitting out there being like, recycle me, we are going to love getting the nickel and cobalt out of them because they're going to have a lot more cobalt in them.
That's
Going
right.
forward, of course, there's a lot of now just one part cobalt, even looking at no cobalt as well. And that's actually better for our process and for our strategic partners that we are going with, because nickel is actually going to be a very high commodity item.
Cobalt in the nickel isn't as appreciated as you'd think from a metallurgy perspective for some strange reasons, including one of them being that superalloys sometimes are used in places where they're irradiated. And so nickel works for superalloy material in that application, but if you have cobalt in it, then it makes hazardous isotopes from that exposure. And so sometimes cobalt is a penalty, and other alloys embrace cobalt, as for its strength and toughness and chemical resilience, in the alloy.
But it's a niche market that's growing
That's
at
right.
between 8 and 20% a year. So as aerospace continues to grow, there is going to be that need for the nickel and cobalt feedstock, and we plan on giving it to them.
So let's talk about the timelines for your company. It looks like there's some exciting stuff coming up. Can you kind of walk us through what's in store for your company?
The plan for our company is definitely to be working with our strategic partners and our investors, and we are finalizing that, we hope, by the end of this quarter. And based on that, we are going to be taking a combination of our self funds as well as our investor funds and strategic partners and grants in order to build that redi-shred truck and have redi-shred out by the beginning of next year. And in parallel with that, we will be developing our prototype plant of the redi-cycle. So we've been able to do pretty okay amounts of recycling, as well as starting to ramp up. And we are looking to start validating some large equipment for production and full scale. And so that'll ramp up in parallel as well, too, as we start to gather that feedstock from the redi-shred truck.
Now, going forward, if things work out the way you're hoping with financing rounds and other things, in terms of your prototypes, where could you guys be, let's say, in 5 years?
I would like to be developing our next generation recycling process in 5 years, which is entirely biologically based and done by GMO modifying nickel complexing bacteria, cobalt complexing bacteria, and copper complexing bacteria. People already use it for bioleaching for mining copper today, but fairly recently, some Chinese university made a cobalt leaching bacteria as well. In 5 years, I would love to see a football field sized leach pond facility running a bioleaching process that's incredibly green and incredibly efficient, handling all the world's e-waste of all types, electronics and batteries, and having low-cost, high-quality output materials from this bioleaching process. And that would be, maybe my 5-year dream, right?
The scale gets pretty intense really quickly. By 2030, based on our calculations, we think there'll be somewhere around 230 gigawatt hours worth of battery material to be recycled. And just to help you understand the weight of that, that's probably around 20 million metric tons of waste. And so, we think it's going to take around 7 redi-shred trucks just to service the United States and the different regions and whatnot. But as far as doing large scale, we think it's going to even go up to maybe 2.5 terawatt hours of stuff to recycle by the time it gets to 2050. And so as that just gets so exponential, you kind of have to start thinking about changing the paradigm a little bit.
Yep. Yeah, this is a steep ramp. All the experts in the world said the rate of EV adoption, by 2020 would be like 0.1% or whatever, and then of course every year they had to recalculate because Tesla's new great, sales rate was blowing the previous year's predictions away. And so this exact curve follows the need for recycling and the volume of material that we get. It's not locked in time sequence with this curve, but it is locked in with this curve. It's just what point it happens is when it needs to happen. But there's all this demand you see in increased EV sales where the electric revolution's happening before our eyes, and we see it everywhere we look, we see EVs. And this exact steepness of curve will be the steepness of recycling curve materials and feedstock and criticality to get in place so that we're not burying ourselves in old EV packs that are sketchy fire hazards to have around.
We cannot strongly say enough that refusing to make product that doesn't survive on Earth is the most important thing when it comes to recycling.
Definitely. Yeah, get that full use of the product. It's a shame every time a pack dies before the cells are worn out in it. You know, that should be a mark of shame for any battery developer. And the industry needs to wake up, learn to respect corrosion.
How hopeful are you that as we scale up EVs and obviously scaling up batteries, that we're going to be able to solve this recycling problem this decade?
Oh, I'm very hopeful because our prototype runs work great, and we already showed, wow, we can eliminate needing peroxide, we can eliminate needing to roast, we can eliminate needing to smelt, and we can still return high purity nickel metal, copper metal. And so I'm incredibly confident. You know, like the process is like the least scary of the whole recycling company for me personally. The process was scary originally, but after a year of doing the process every day and perfecting it, the process is not scary anymore. It's pretty repeatable and reliable.
There's a lot of great minds working on this issue. And so if you have hope in the human race, I think that there's hope for us to solve this issue. I think one of the major things I would love to see people focusing on is more about making Earth and humans survive the future generations like we talked about, rather than chasing after some sort of currency that doesn't necessarily mean anything other than the power that we give it.
A fictitious human constructed fiat currency is traded for your survivable ecosystem, which is a fool's game, you know, and the sooner we stop playing it, if we don't stop playing it, we die as a species, basically, is the way it works.
But to that point, you guys need investors, and we're talking to a lot of people out there who probably are excited right now to want to invest in your company. What should people do if they want to reach out to you to talk to you more about investing in your company?
Well, depending on which one you're really excited about, you can go to redi-shred, redi-shred.com, or redi-cycle, redi-cycle.com. And they'll take you to our company page where you can send us a message. There's definitely info a bunch on the website as well too. And as soon as we begin our talks, we're more than happy to share information as far as what we're working on.
That's great. So how soon do you think you might have a prototype ReadyCycle truck out and about that we could maybe come visit?
We'd love to bring you out as soon as we have it ready to go, maybe even while we're building it. So hopefully on the road, you'll see it early next year. And we're going to have a lot of fun this year building it up and getting people excited about us being able to help them out with their batteries.
That's really going to be exciting. I mean, because I'm excited about going, like, picking up the Cybertruck, but I'm also really excited about seeing your ReadyCycle shred truck, because I mean that's a solution that we need.
Yep. Oh yeah.
Wow, I'm like so honored that you put us on that same level, because I'm really looking forward to our Cybertruck too.
That's the thing. I mean, we need both. Like, everyone's so excited about, Cybertruck and the Roadster and all these things. But if we don't have a way to recycle these batteries, like you said, we have a huge problem.
That's very true.
It's not the glamorous challenge to overcome, but it is a great one for the positive effect it has on our survivability and continuation on this spaceship.
We're so grateful for the interactions and the excitement that we have. We get a call pretty much every day saying, when can you come pick up our batteries? And we're really excited to be able to give those dates.
It's a blessing for the opportunity to do good things in the world at a big scale. Like, what a blessing. Couldn't ask for more.
I agree. I'm so grateful that we get to partner together as well too. It's been such a blessing and so much fun every single day. And that's what really keeps driving us to move forward. Our friends and colleagues ask us all the time, how do you work so much? Why do you work so much? And I think that we just continue to be inspired by those around us, and we inspire each other. And because of that, we feel like there's a lot of hope.
Yeah, I agree.
That's awesome. Thank you so much, guys, for hanging out with us today. This has given me a lot more hope, and I can't wait to see more about what you guys are working on.
Thank you.
We're so glad. Thank you so much for having us.
Our pleasure.
Thank you so much for watching this episode of Disruptive Investing. Be sure to like the video and subscribe. Click the bell button to be notified when new videos come out.